Hello, my name is Robert Toomey, and this is my quick project explanation for GIS 540 Programming Fundamentals. I took this class at North Carolina State University in the spring of 2015 as part of the GIS Master's graduate program there. Let me start by telling you a little bit about myself. I'm a software developer at the National Severe Storms Laboratory in Norman, Oklahoma, and my primary job focus is on 3D visualization of weather data. This has led me more and more into the study and application of GIS techniques, especially when applied to meteorology and hydrology. In the past, I've worked a lot with Java and C++, but this class this semester has introduced me to the Python programming language and using ArcPy for geoprocessing. At the National Severe Storms Laboratory, we have many custom NetCDF datasets. There are lots of advantages to having a custom dataset format. One of those is that the format can be quickly changed or adopted if needed. You don't have to worry as much about people on the other side of the world having to know about changes you made. You can also tweak the data format for your particular needs. For example, standard NetCDF files used to not support certain types of compression. With our own format, we were able to shrink our files quite a bit. This is important because we have real-time systems processing weather data continuously as new data comes in. Of course, there are also disadvantages to having custom data sets. It's harder to share data with people that don't know the format. Also, to display the data, which you want to do for papers and presentations, it is more difficult. We use a custom in-house GUI display system, but presentation is limited to the features that display has. So by importing to a standard, we also have access to more graphical tools such as ArcMap. For this project, we had a couple of main goals. The first was to apply the newly learned Python and geoprocessing skills using ArcPy. We wanted to work with Arc toolboxes, the Arc Toolbox GUI parameters. For example, letting the user graphically choose files and settings and running the toolbox, and things like showing dialog processor bars while running a batch script in the ArcGIS system. I also had a secondary goal. I knew that the project I've defined is larger than the scale of a class project. It will have to grow and be enhanced and changed over time in order to be useful to scientists here. We'll need to add more data formats and toolbox abilities. Eventually, I might have to have students or others working or contributing to the code as well. For this reason, I also wanted to create an open source GitHub project with a code base. To see this project, you can go to the following link at https://github.com roberttoomey.python. Basically, GitHub lets you store code in a repository. Repositories are a document control system to let multiple people easily work on the same Python scripts without stepping on each other's work. GitHub is also neat in that it allows you to download the latest and greatest copy of the code at any time. So for this project, we created two GUI toolboxes to use inside of ArcMap. The first toolbox allows us to import a single NetCDF file containing a Woods2 lat-long grid file format. We wanted to do a few things here. First, auto-detect and handle raw NetCDF and/or gzip compressed NetCDF files. Second, the toolbox would convert the file to a raster and auto-load it into ArcMap as a layer. The goal of this was to model ourselves similarly to standard conversion toolbox tools such as point to raster or polygon to raster. Also, we added the ability to optionally create a PNG image of the raster data and create a PNG image of the data with a USA map and symbology within an HTML file. For the second toolbox, we expanded upon the first one. For this one, we allowed the user to choose an input directory containing data files. The toolbox then walks the directory and generates a raster from every file that is recognized and stores it into a newly created geodatabase. If the user turns on HTML PNG generation in this case, it will generate a PNG output image and HTML page for each file. It uses a symbology file and USA map file to zoom into the image and create a PNG of it. Finally, we generate an index.html table of contents that lists all of the generated pages. Why do we do this? Most of our weather data is in time series. By generating the pages this way, a user can click a next or previous link to move forward and backwards in time. This allows them to browse visually the time-based output of the weather data. Imagine the standard weather looping you see on the television station. Well, that does it for the introduction. Like they say, a picture is worth 1,000 words. So next in the demo video, we'll check out the results and give some conclusions.